In today's lesson, we're going to continue our study of lines and the equations of them from yesterday. We're going to look at some of the situations that are slightly more challenging or just necessary to deal with. So just to get started, we'll review what we did yesterday. So I want to find the equation of a line. We said yesterday that's always mx plus b unless it states otherwise. That has a slope of -5 and passes through a point. So we said yesterday, if we know a slope, which we're given, start by filling that in. All you need to do is find b, the y-intercept. We can do that if we have a point, an x and a y. We substitute those values in for the x and the y, make sure they're on the right sides. We can pretty quickly solve for that b by doing some pretty basic algebra. Okay, so expand your brackets, rearrange it, and b is 19. So the equation of our line is y equals -5x plus 19. If we try the second one, this time we're given 2 points. Well, if we know 2 points, we can always find our slope. Our slope is y2 minus y1, so 2 minus 9 over x2 minus, and be careful here, minus -4 x1. We end up with -7 over +2. And here, because we don't get a very nice number, we can divide this, make a decimal, nothing wrong with decimals. So -3.5, there's our slope. Once I know my slope, it's back to the same kind of question. Fill in what we know. Y equals -3.5x plus b. Pick a point, an x and a y that you know. You actually know 2, so you can use this one, or you can use this one. I'm going to use the 2 one because it's smaller numbers. So y is 2, x is -2. Careful with all your signs. Expand our brackets, we get 7, 2 minus 7 is b, b is -5, so our equation is y equals -3.5x, don't forget the x, minus 5. Okay, these two both worked out pretty nicely. We had whole numbers for the first one, we had nice decimal for the second one, but what about the situation where we don't have nice numbers? How are we going to deal with that? So, if we have a fraction, we have two choices. We can deal with fractions, knowing our fraction rules, adding, subtracting, multiplying, or we can use the fraction button in your calculator. I'm not really picky which. I think the fraction button is a little bit easier from your calculator, but you're going to have to go back and remember how that works. So let's try one here. I want the equation of a line as a slope of -1/3. I can't divide that with my calculator because it doesn't come out to a nice decimal. I actually have to use the fraction. Everything else is the same process, just we're dealing with fractions now. So y is -3, x is 5, and we can expand our brackets. Now here you have to remember the rule that when you do fractions, you go straight across. So we get -3 equals -1 times 5 is 5, 3 times 1 is 3. We rearrange it like we always would, so bring it over to the other side. And here, because I have fractions, I need to make a common denominator. My common denominator is going to be 3. And the second one's already good to go. But the first one, to turn it into a 3, whatever I do to the bottom, I have to do to the top. So I get -9. Adding fractions, or subtracting fractions, just collect your terms on top. -9 minus 5 is -14 over 3. And there's b. Now, if you used your fraction button, you wouldn't have had to show all that. You could literally have just typed in to your calculator -3 minus 5/3, and it would have given you -14/3. But if you're not sure how to do that, you can always use the fraction version. Don't forget at the end, write down your equation. Okay, that's what we do with messy ones that involve fractions. All right, you guys can try one. It's kind of like the second example we did today. Just guessing it's going to result in a fraction. So m equals -6 minus 7, -2 minus 4. That's -13 over -6. I can make it a little bit prettier to work with, make them both positive, because 2 negative makes a positive. So y equals 13 over 6, x plus b. Let's pick a point. I'm going to use the positive one this time. I just think it's easier to work with positive numbers sometimes. So 13 over 6 times 4 plus b, 7 equals, we're going to multiply straight across. 13 times 4 makes 52. 6 times 1 is 6. I need to rearrange so I can solve it. 7 minus 52 over 6 equals b. I need to make a common denominator, so 6 and 6. If I times this by 6, I have to times that by 6. So we'll get 42. 42 minus 52 is negative 10 over 6. And because those are both divisible by 2, we should reduce it, and I get 5/3. Therefore, my equation is y equals, go grab your slope from up top, 13 over 6. Don't forget the x, minus 5/3. And if you use your calculator way back up here for 7 minus 52 over 6, it would have reduced it right to 5/3 right off the bat. That's why the calculator is a little bit handy to work with sometimes. Okay, those are fraction ones. The other problem we're going to come across today is some special lines. There are two types of special lines we may come across: vertical lines and horizontal lines. And how we approach them depends on the type of equation that they have. So we'll look at vertical lines first because they're the messiest ones. They're the weirdest ones. They don't even have a slope. If I were to take 2 points off this graph, so for instance, 3, 0, and how about this one, 3, 4, and try to calculate the slope, I would get 4 minus 0 over 3 minus 3. I get 4 divided by 0. And if you try and punch that in your calculator, it's going to say the word error. You can't actually do it. That number is not defined. It doesn't actually exist. Vertical lines have no slopes. Okay. What they do share is they all share a common value. Every dot on this red line starts off with 3 and something. 3 and something. Because they all share that 3, the number at the beginning, the y part doesn't really matter as much. We say the equation of this line is x equals 3, the number that they all share. So if I want to find other vertical lines, I could go over here and draw one like this. This would be x equals negative 1 because it goes through negative 1. This one over here would be x equals, if I counted 1, 2, 3, 4, 5, that would be x equals negative 5 because every point on that line is negative 5 and something. Negative 5 and 1, negative 5 and 4, and so on and so on and so on. So if you come across an equation that starts off x equals, you know what the vertical line through that x value. On the other hand, you have horizontal lines. They have a slope of 0. So again, if we look at this line here, the dot on this line might be 0, negative 2, and another dot might be 1, 2, 3, 4, and negative 2. If I'm trying to find its slope, I get negative 2 minus negative 2 and 4 minus 0. I end up with 0 over 4. That I can calculate. 0 divided by anything always comes up to 0. And that's true for every horizontal line. So if you come across an equation that doesn't have a slope of 0, you know you've got something horizontal. Something else you might notice about this line is every point on it shares a value. I got negative 3, negative 2. I've got 0, negative 2. I've got 4, negative 2. I've got negative 6, negative 2. Hey, they all have the exact same y value. They're all negative 2. So we see equations of horizontal lines are always just y equals and whatever your shared value is. In this case, negative 2. Okay, so again, you could draw more lines. You could say, here's one. That's y is 2, a constant. Here's another one, y is 5. Okay, those are two special lines. So, no problem solving here. Can you write down the equation for a horizontal line through 3, 4? So I need to think about that for a second. 3, 4 is like here. I want to be horizontal. 3, 4. Well, horizontal lines are always y equals. And what's the y value? 4. Done. Vertical lines are negative 1, 2. Okay, so they're x equals. And what's the x value? Well, that's quick. It's negative 1. If that didn't make sense, take a look at the picture. Negative 1, 2 would be about there. And every point on that line would have a shared x value, right? Negative 1 and negative 4, negative 1 and negative 5, negative 1, and so on, so on, so on. Okay, part C. It's got to pass through 2 points. Well, usually when we find passing through 2 points, we find our slopes. So negative 5 minus 9, negative 4 minus negative 4 gives me negative 14 over 0. Oh, I can't divide by 0. That's weird. Okay, what does that mean? It means it's an vertical line. What, if you maybe had noticed in the question, is your x values are the same. That is the hint that it's a vertical line through negative 4. If you try D, you might notice something kind of similar. Hey, I got a y of 5 and a y of 5, so my equation, it's got to be 5. If they have a shared value, it's either a horizontal line or a vertical line every single time. It has to be. Okay, last one. Can you find me the equations of the 3 lines? So we've got a regular line, diagonal one. We've got a horizontal line. We've got a vertical line. If they're horizontal, those are quick. They're y equals. What's the y value? 1, 2, 3, 4. Done. If it's a vertical line, those are x equals. What's the x value? 1, 2, 3, 4. Done. If it's a diagonal line, those are the slightly tricky ones. They take a second to do. But the nice thing is we've got ourselves a picture. So I can find 2 nice points. I think this is a nice point here, negative 2 and negative 4. And I think there's another nice point right there, 2 and 2. I can count my rise. My rise is 1, 2, 3, 4, 5, 6. And my run is 4. So a rise of 6, run of 4. And my y-intercept, I can see it, it's right there, of minus 1. And we can simplify that just kind of. And there's your equation for that diagonal line. So just a little more practice with dealing with lines, fraction ones, messy ones, or these special kind, the vertical and the horizontal. Okay? And there's the homework you should be trying from your book.